Okay. So today, now we are going to go ahead with the next topic, that is mm, uh, the that is Q. So in our day-to-day life, we come across this particular queue. So whenever you go, for example, you go for a railway reservation counter, where you will stand at the back, right? As the people are being serviced, the servicing is always done from the first, right? So the same thing. For example, I have a common resource of printer. For example, there are 60 systems in the lab which are connected to it, and in that 60 people are working. 10 people have given the print command. Okay, so when the print command has been given, the whenever it has been received, they are going to be held in a they are going to stand in a line, right? So one operation is completed, right? Then it will go for the next operation. So like this it would be in the queue. Okay, one after the other it is going to be serviced. Okay, so this is what is nothing but a queue. Okay, and printer facility. Okay, similarly when you are scheduling operating system, okay, when the your processor is using, for example, round robin algorithm. Okay, so there are, for example, this there are five jobs are getting done, five tasks, right? So the processor is going to be used by one particular task, but it is going to be used by everyone. So how does it do? It switches over from one task to the other task after 10 milliseconds or 50 milliseconds, like that. Okay, so when the task is there, task 1, task 2, task 3, task 4, task 5, right? So first task 1 is has come, so it will service for 10 seconds. Then it goes to the task 2. Then task first in the task 1 is not completed, is complete this one, it will be in the line after task 5. After task 2, again 10 second millisecond, it may go to task after task 1, again it stands in the queue, right? So it is nothing but a queue, right? Where one after the other the servicing is going to be done. Okay, so now this is what is a live examples of where the queue is going to be implemented. Okay, so for example, CPU scheduling, right? Or you take any resources scheduling, right? For example, you are using any resource, example is your printer. Okay, so all these things are the examples where we are going to use queues. Okay, wherein, right? So let us see what is a queue. Where if we define a queue, like what is the stack we have defined? Stack is a linear data structure wherein the operation of insertion and deletion takes place only from one end, called a stop, right? That was a definition you called, and which follows the principle of last in first out. Okay, now let us write q is a q is a linear data structure. We call it is a linear data structure. It is not linear, it is a linear data structure which follows the principle of FIFO. FIFO. FIFO means first in, first out. First in, first out policy, right? And the operations of insertion is done from back, called rare, and deletion is done done from from front, from 10 front. Okay, so there are two things which we are going to maintain here. Now for example, this is the queue, let us assume. Okay, so this is the queue, these are the places, right? So first, initially when we have the element, no elements are there, right? The front and rear would be at the same position. Now, for example, an element 10 is inserted. Okay, so this is the front element. This is front. Okay, rare is here. Rare is here. Now, okay. Now, after inserting, for example, 15, then rare will move to this place. Rare becomes here. Rare becomes rare is equal to rare plus 1. Rare is always pointing to the location where the insertion of the element has to take place. Front always points to the element, frontmost element, the element which has to be deleted. Now, for example, I insert 25, 25, then automatically rare gets incremented and rare moves to this next location. Okay, right? And then, for example, I'm next, I'm deleting, I'm putting one more element, 40, right? Then rare gets incremented, and this is the rare position. This is the rare. Okay, for example, I've inserted one more element, 22, right? So what will happen? Rare gets to the next to this one, rare. Okay, rare moves to the next. So whenever you are moving the rare, for example, if you are assume that we are implementing it using first is we are implementing using the array. So we are going to follow the subscript 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this particular queue is of size 10, let us assume. Queue is of size 10. If Q is of size 10, the first subscript is 0, second subscript 1, 2, 3, 4, 5. That is 10 locations are available. Now rare is pointing to which location here rare now in present scenario, okay, rare is equal to 5. That means it is pointing towards the location 5 means that is the location where it has to be inserted. And also front is pointing to 0, right? Front is, now let us assume that we are deleting one element. We are deleting one element. Okay. Now when we delete an element, okay, then what will happen? This 10 is deleted. 10 is there. So automatically front is not, now there will not be any movement. 15 will not move to 0 location, 25 will not move to 1 location, 40 will not to, no, it won't move. What will happen here is automatically front which was at 0 will move to the first location. Your front will become here, right? Means, okay, um, front will move to the next. Now, for example, first, what are the operations which you have done? I have done insert 10, then I have done insert 15, then I have done insert 25, then we have done insert 40, then we have done insert 22, then I have told delete. When we have deleted 10. Now again I say delete. Delete means what is the element which gets deleted next? 15 gets deleted, and front will move to the next location. That is this is front now, right? So in both the cases, when an insertion takes place, when insertion takes place, right? Rare would be equal to rare plus one. That is rare plus plus is going to be done, right? When deletion takes place, when deletion takes place, okay, then front will be equal to front plus 1, that is front plus plus, right? Where in the stack we had only one variable when we are implementing using the what is that called, when we are implementing using the array we had only one variable, that is top. So either top plus plus is going to be done or top minus minus. Top plus plus was done whenever you had a push operation. Top minus minus you used to do it whenever you had a pop operation. So here there are two ends, that is the front end and the back end, right? So back end you are going to push, that is whenever the insertion of the element takes place, it takes place from the back, rare, and whenever the deletion takes place, it takes place from the front, right? So now what will happen here is you are deleting the elements from the front, so front will keep on become plus plus, right? When you are deleting the elements from the back, right, and when you are inserting the elements from the back, then rear will become rear plus plus, right? So like this it keeps continuing, it keeps continuing, right? So now here let us see, I will do the next operation, continue. I'll say insert 50, then I'll say insert 29, right? Then I'll say insert 45, right? Then I'll say insert 60. So what are the this one? I told first 50 insert, then I told 29 insert, then I told 45 insert, then I told 60 insert. So now rare would be here, rare would be here. Okay, now I'll say insert 90. So 90 is inserted here. Now rare is going to this particular place, rare, rare, wherein rare value has become now equivalent to 10. Rare value has become equivalent to 10, but there is no 10 subscript here. Why? Because my size of the array is a q of 10. That means q of 0 to q of 9. That means rare can take value here, rare can take value from from 0 to 9. That's all, 0 to 9. Okay, rare cannot be 10. If rare has become 10, that means that my particular queue is full now. Queue is full. You cannot insert any more element. Now the question doubt will come, sir. Why are it is full? There are locations which are available in the front. That is 0 and 1 are not used, right? It is available. But however, we will not use that now. We are now discussing about the linear queue. This is what is the disadvantage of this particular queue. So whenever the rare value becomes greater than or equal to the max, if I say this is max, 10 is, this is for example, let us, this is take max, right, max, then what will happen if it is greater than or equal to 10, that is greater than or equal to max, then we are going to say that the queue is full. The queue is full. Queue is full. Is this clear for everyone? Any doubt still here? Then I'll go to the next page, draw the same diagram and do the next stop. Take one more example and do it. Is the queue is full? None. So I'll write for the condition when the queue is full. Queue is full, right? When max is greater than or equal to, sorry, rare is greater than or equal to max. Is this condition clear now for the queue, right? And what is, remember, we are implementing this by using what now? We are implementing by using array, right? Array, not linked list. In the linked list we are going to see next, right? So understand when the queue is full first, right? So what are the operations which are again possible here is same, the queue, insert operation, delete operation. There is no separate, right? But generally we call it as NQ, DQ, right? Okay. So our insert, delete. And similarly, you can see which is the frontmost element if you want, you can see, right? That is not a problem. Okay. Or what is the next operation is the print the elements of the queue. From front to rear, you are going to print the elements. Okay. So these are the things which are very important for us. Is the queue is full is clear, then we go to the next part of it, that is when the queue becomes empty, we are going to see now, right? Okay, so taking for example, assume that uh, the queue is like this. 0 1 2 3 4 5 6 7 8 9. Okay, 10 means okay, don't take the 10th one. Max is equal to how much here? Max is equal to 10. Okay, so we have already taken this one. Now tell me, for example, let us assume that my elements now are at what is 45. Okay, 50 and 55. These are the elements. Now tell me, where is my rare? Can everybody tell me what is the where is rare and where is front? Tell me what is the rare value of rare and what is the value of front? Everybody unmute and tell me what is the value of rare? Where is rare? Rare is at which location? Rare is always pointing to the location where the insertion has to take place. So where does the insertion takes place in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9 locations? Tell me in these indices.
Six.
At 6. So this is what I can say. This is rare. So rare, therefore rare is equal to year 6. And what is front? Front always point to the frontmost element. This is front, right? Therefore front is equal to how much value? Front is equal to not the element. What is the subscript? 3. Subscript is 3. Now do one delete operation, do another delete operation, do another delete operation, another delete operation. Okay, right? So when you do delete operation, what is deleted? 45 is deleted. Therefore front is equal to front plus 1, that is 3 plus 1 is equal to 4. Got it or not? Then that is 45 is deleted. So front is not here now, front is here. Okay, next 50 is deleted. Therefore front is equal to, okay, 4 plus 1, that is equal to 5, right? So 50 is deleted, so front is moving to this particular place, front. Got it or not till now? Now delete one more operation, that is 55 is deleted. 55 is deleted. That is what is happening now. 55 is deleted means your 55 is deleted. Therefore front is equal to 5 plus 1, that is equal to 6, right? So front is move here, and front is also pointing towards what now? Rear. Front is also moving there. Now tell me, does any elements are there in this or not? Any elements are there? Tell me. Now does any elements are there or not? Please speak out. Any elements are there? Yes. No elements, right? So if front is equal to rear, then we say that the queue is empty. And this is what is initially, right? when we initialized when we initialized front is equal to 0 and rear is equal to 0, you take it first initialization. First when you have started, this was the one which we have started when no insertion has taken place. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. At this time the front was here only and the rear was also here only, which was front is equal to 0 and rear is equal to 0, right? But at that time also front is equal to 0, rear is equal to 0. Front is equal to here also front is equal to rear, right? Therefore q is empty. Q is empty. Is the empty condition clear or not? So what is the condition for this one? For empty, the queue is empty is if front is equal to rear, then we say that the queue is empty. Is this clear or not? Right? Is this clear? So in the case here, in this particular case also, you see front has become equal to the rear means there is no element which is there. Okay, now for example, if one element is inserted, what will happen? Rear front will rear is going to become now 6 plus 1, it moves to the next one, right? So very simple. So insertion means nothing but where is the insertion? Q of rear is equal to value. Deletion means value is equal to Q of front, right? Q of front value, assign it to delete. That's all. That's how we are going to do it. So the condition is very very clear, right? Now one more case I'll tell you. When the queue would be dead, when the queue would be dead, for example, let us take this is what is a queue, right? So now my for example your values are like this now: 5, 8, 15. These are the values which are there. Now where is the friend? This is rare, right? My friend is here now also, friend. Now once you do the delete operation, one delete operation you do it, second delete you do it, third delete you do it, what will happen? 5 is out, then the front is here, 8 is out, then the front is here, okay, then 15 is out, front is also has become equivalent to, that is front is also what, equal to rare. But remember, front is also become greater than or equal to max, greater than or equal to max. So it's very very important, when front is greater than or equal to max, then q is dead. Q is dead. You cannot use this q anymore. That means your q is over. Your q is over, right? So this is what is the disadvantage of it. But actually speaking, this particular queue is alive. Actually the queue is there. Why? Because these particular locations can be, you can store it. So after the this particular value, why can't we come back to this particular place after 9? Can we come to 0? We can come to 0, we can come to 0. But that is what this is the disadvantage of this, which we are going to overcome this disadvantage in the circular queue. Okay, so this is what is the concept of a linear queue. So in the next class, we are going to, tomorrow's class I'll implement using arrays, right? We'll write a program for you, right? I'll write the function of insert and delete, and again using linked list, what is the program for that. So tomorrow we are going to do the linear queue. Okay, linear queue. We are going to do both the array implementation and linked list implementation. So by this time you should have got it to your mind. I'm just giving a hint of linked list representation. You have the nothing but this is taken as one node, second node, third node, fourth node, like that. So the deletion takes place. The first node has to be deleted. Insertion has to be the last node. Now tell me, implementation of queue is over. What is that? Implementation of queue. Insert means it has to be the last node adding concept you are going to do. Delete means first node deletion concept you are going to do it. That is what. So for maintaining the pointer front and rear, front is nothing but start, rear is nothing but last. That's all. So you're maintaining two pointers, front and last. Front and that is front and rear. What is front? Front is start, rear is last. These are the two pointers. Over, you know the linked list representation, how to do it, linked list this one. And now you see how you know the concept of queue, how easy you can implement it. So my represent my this one onwards, now onwards, will be only to tell you only the concept of it, but implementation of it, when it comes to the program, you will write the program. Now onwards, we will not write the program. Okay, because I have told you what is the queue, right? And what is, how the insertion takes place, how the deletion takes place. Then you have to implement it. You know the linked list. Okay, so this is what so there are including me, 59 should be there. Two students absent, 214 is absent, and 213 and 214. That's all. These are the two, right? Anybody else outside student is sitting in this class by chance? Karthik, stop recording, Karthik, now.
Yes, sir.